Cambridge Ideas, transforming tomorrow.
We're very used to the idea that water is life, but maybe we're missing a trick here. Where there's no water, is it possible there could be some life there? I'm Alan Tunnacliffe, and I've spent 10 years trying to understand dry life. Here is a plant called a resurrection plant, and it's well named. Like this, it looks very, very dead. But you add this back to water, and it comes back to life within a short time. This is yeast. These are living cells in this dry form, but they come back to life when you add water. Just add water. What is life? How can it survive without water? Are these organisms telling us something we don't know? Human beings are about 2/3 water, so if you lose 10–15% of that, you're as good as dead. But some remarkable organisms can survive loss of almost all of their water, and in this dry state they become very, very tough. So this is the kind of thing we work on in my laboratory. This is muck from the bird bath in my back garden. It's dry, it's horrible looking, but in here you'll find tiny little creatures just visible to the naked eye, called deloid rotifers. You find them everywhere on the planet, and these are expert survivors. So in this vial we have several thousand rotifers, and they've been dry for 4 years. We're going to see just how tough they are. Throw them in some boiling water and see what they make of that. The next thing we're going to do is put them in liquid nitrogen. It's minus 196 degrees centigrade. Here's a rose. That's really well and truly frozen. So cold that it shatters when we take it out. Let's get them out of the boiling water. Okay, from plus 100 to minus 196. So let's leave them to warm up a little bit. Can they withstand these extremes of temperature and come back to life when we add water? So let's see if any of them are going to wake up and come back to life. Yeah, you can see them stretching, waking up from their long sleep, like Sleeping Beauty. Yeah, they made it. So they're pretty hard to kill, these guys. When they're dry, these rotifers can survive extreme conditions. Very high temperature, very low temperature, very high pressure, and even extreme amounts of radiation. Radiation so intense that it smashes their DNA into little bits. So when it rains and these organisms find water again, they can magically stick together all these broken bits of DNA into one long molecule again. And that's already impressive, but they can also do something even stranger. They can take up DNA from other organisms which they find in their surroundings and knit those bits of DNA from other creatures into their own. So these animals are actually genetic mosaics, and that's really quite strange. And I spent the last 10 years trying to work out just what molecular magic tricks they use to do this. We've discovered something really interesting. This is part of the animal. The blue is DNA, and the red is a special kind of protein, which we call a molecular shield. And it's everywhere inside the animal, protecting all the other parts of the animal in there. Think of amber. Animals in amber look like they do because they're trapped in the resin. They've stopped interacting with the universe, and they're outside time and space. In rotifers, when you add water, everything changes. The animals are unlocked from their molecular prison. And just like Sleeping Beauty, while the world around them changes, these animals are just the same as they were before. Perhaps the most powerful test of how well we understand this phenomenon is if we can transplant it into another cell or organism. In outer space, conditions are extremely harsh. We have very low temperature and pressure, and very high levels of radiation. Some people ask me, Is it possible we could improve astronauts to survive these conditions like our rotifers do? Well, probably not. But if rotifers can survive these conditions, perhaps some life can travel through space. And when we look for life on other worlds, we might find it where there is no water.